Now let's look at another right triangle. This is the right triangle. Right. If this side is A, this is theta. And if this side is B, and this side is C. And we notice that since this is a right triangle, right? So this is 90 degree. So in other words, the sum of these two triangles should be equal to 90 degree also, right? Because the sum of the triangle should be, the angles in the triangle should be equal to pi or 180 degree, right? Since here is 90 degrees, so the other two, the sum of the other two should be 90 degree or pi over 2. Okay, so since this is theta, if we know this theta, so the other one is, this one should be pi over 2 minus theta, or 90 degree, if we use the degree minus theta, right? So these two angles are complementary angles, right? Complementary angles, because the sum is equal to 90 degree or pi over 2. So now let's look at the sine theta. Sine theta is B over C, right? Let's look at the cosine theta. Cosine pi over 2 minus theta, which is also equal to cosine pi over 2, which is this one, right? Pi over 2 minus theta, which is this angle. So cosine is the adjacent, which is B, over hypotenuse C, right? So this adjacent means the adjacent to that theta, right? And this B is the opposite of the angle theta. This B is the adjacent to its complementary angle, right? So you can see these two are the same, right? So the cosine theta should be equal to cosine pi over 2 minus theta. Okay. Similarly, you can also get cosine theta is equal to sine pi over 2 minus theta. And we have tangent theta is equal to cotangent pi over 2 minus theta. Or cotangent theta is the tangent pi over 2 minus theta, right? And you have secant theta equals cosecant pi over 2 minus theta. Cosecant theta equals secant of pi over 2 minus theta. Okay, so these the left side is theta, right? These identities. The left side is theta, the input is theta. The right side is the input is pi over 2 minus theta, which is the complementary angle. And the function, the left side is the function, trig functions. The right side is called cofunctions. Sine becomes cosine. Tangent becomes cotangent, right? So secant becomes cosecant, right? So one function is the cofunction of the other one, right? The left side or the right side is the cofunction of the other side. So this one gives you this result that the cofunctions of complementary angles are equal. are equal. Very important result. The cofunctions of the complementary angles are equal. So we can use, so one of the function is the cofunction of the other one, and the angles are the complementary angles, right? You can see. Okay, so we want to use this result to calculate this one, cosine 40 degree over sine 50 degree. And we know that cosine 40 degree is equal to, we use the cofunctions. The cofunction of cosine is sine, right? And then its complementary angle, which is 50 degree. So the sine of 50 over sine of 50. So this is 1, right? This is another example. Sine 5 pi over 12 over cosine pi over 12. Okay, so now let's look at the sine. The cofunction is sine, cofunction of sine equals cosine, right? Cosine. The complementary angle of 5 pi over 12 equals pi over 2 minus 5 pi over 12. So this is the cosine pi over 12. And this one, you can see the top is actually pi over 12 over cosine pi over 12. So this one is equal to 1, right? So sometimes it's useful, simplify your calculation. Let's look at this one. If we have the cosecant theta equals 6, right? We want to know the first thing, what is sine theta? Sine theta, we know it's equal to the 1 over cosecant theta, right? So this is the 1 over 6. It's the reciprocal identity. What about cotangent square? Cotangent square, we know we have the identity cotangent square plus 1 equals cosecant square. So this one is cosecant square minus 1, right? This is the Pythagorean identity. So this one is equal to 6 squared minus 1, so this is the 35. What about cosine pi over 2 minus theta? Okay, so this is the cofunctions of the complementary angles are equal. So the cofunctions of cosine, which is sine, right? The complementary angle pi over 2 minus theta is theta. So we know, we just calculate it's 1 over 6, right? Fourth. What about the secant pi over 2 minus theta? Secant pi over 2 minus theta. So the secant, the cofunction of secant is cosecant. Cosecant pi over 2 minus theta, the complementary angle is theta. So cosecant theta is, we know it's equal to 6. So now let's look at secant square. Okay, so we have no direct identities, right? Not like the previous 4. The idea is the most efficient way is to draw a right triangle, right? Like we did in the previous example. So cosecant equals 6. So that means if you draw a right triangle. If this is theta, cosecant is what? Is hypotenuse over opposite. So 6 can be written as 6 over 1. If we said this one is 6, here is 1. Right? The cosecant theta is 6 over 1. So we can use the Pythagorean theorem, and so this side is 6 squared minus 1 squared, so this is square root 35. Okay, so the secant square is what? Second is hypotenuse over adjacent, right? 6 over square root 35. Then don't forget it's square. So this is 36 over 35. So now we want to calculate the trig function value for some special angles. Okay. Computing the trig functions of special acute angle. Okay, so the first thing is, what are the special acute angles? So these are three special acute angles. Which is 30 degree, 45 degree, and 60 degree. The corresponding radians is pi over 6, pi over 4. This is pi over 3. You should be familiar with that. So now the first thing, let's look at the 45 degree. Which is the 45 degree, which is pi over 4. In order to get the trig function values for this 45 degree or pi over 2, we can draw which is called an isosceles triangle. Isosceles triangle. So this is the isosceles triangle. Okay, so that means these two sides are equal, so we set this one to be unit 1 and this unit 1. Then we can calculate this side by the Pythagorean theorem. This is 1 square plus 1 square equals square root 2. Right? Isosceles triangle is, here is pi over 4, right? So here is also pi over 4. So now we can calculate sine pi over 4 or 45 degree which is what? 1 over the opposite, which is 1 over the hypotenuse, square root 2. Okay, some textbook write as a square root 2 over 2. It doesn't matter. These are exact same. And cosine pi over 4, which is cosine 45 degree. So this is also adjacent 1 over square root 2 hypotenuse. So you can write it as square root 2 over 2. Tangent pi over 4 equals cotangent, this is the 45 degree. So it's equal to opposite over hypotenuse, adjacent, so it's 1 over 1, so this is equal to 1. Okay, then the other three, cosecant, which is 1 over sine, right? Secant is 1 over cosine. Cotangent is 1 over tangent. So you can use the reciprocal identities to get the other three, right? So these three are the most important one you should know. Because the other three, you can use the reciprocal identities. Okay, so now let's look at another one, which is the 30 degrees and 60 degrees, or pi over 6 and pi over 3. Okay, so let's draw equilateral triangle. The reason is the equilateral triangle has all three angles exact same, which is equal to what? Equal to 60 degrees, or pi over 3. Equilateral angle, so three sides are equal. Okay, so this is the pi over 3, 30. This is the pi over 3. Okay, so now let's draw from this point, we draw a perpendicular, the height of this triangle. So these two angles are the same. So it's 1/2 of the pi over 3, which is pi over 6, right? This angle is pi over 6. And since this is a perpendicular line, so this is the right triangle. Okay, if we set this part to be 1, since this is the middle point, right? So this side should be equal to 2. So this is an equilateral triangle, so each side are exact same, so this side is 2. Okay, so we can use the Pythagorean theorem to calculate this side. This side is square root 2 square minus 1 square, which is square root 3. Okay, so now let's calculate sine pi over 3, which is equal to sine 60 degrees, right? So this is the opposite. Opposite is this height, square root 3 over hypotenuse, which is 2. And the cosine pi over 3 over equals cosine 60 degrees. So this is the adjacent 1 over hypotenuse, so it's 1/2. Tangent pi over 3, which is equal to tangent 60 degrees. So this is opposite over adjacent, so this is the square root 3. So we look at this angle, right? Pi. And then we have the pi over 6, sine pi over 6, which is sine 30 degrees. Okay, so which is the opposite? Opposite is this side, right? Which is 1 over hypotenuse is 2. Cosine pi over 6, which is equal to sine, which is equal to cosine 30 degrees. So this is square root 3 over 2. Okay, or it's equal to sine 60 degrees, right? We can use the cofunctions of the complementary angle. And the tangent pi over 6, which is pi equal to tangent 30 degrees. So this is the, which is 1 over square root 3. Or you can write it as square root 3 over 3. So these are the results you should know, okay? You should be very familiar with that. Let me write down the table. So this is the pi over 6, which is the 30 degrees. And this is the pi over 4, which is the 45 degrees. This is the pi over 3, which is the 60 degrees. And this is the sine function, cosine function, and tangent, right? Tangent sine is pi over 6, so 30^1/2. And this is the square root 3 over 2. And this square root 3 over 3, we just calculate, right? So this is the square root 2 over 2. Or you can write add 1 over square root 2. This is square root 2 over 2 also. And this is the 1. And here is square root 3 over 2. And this is 1 over 2. This is square root 3. So you should memorize this table. Okay, so after you memorize this table, you can calculate something very quickly. 45 degree times cosine 30 degree. So we know 45 degree, which is square root 2 over 2, right? Times cosine 30 degree, which is square root 3 over 2. So this is the 4 here and square root 6. Okay. So here is we let our theta is between 0 and pi over 2. And we know that cosecant theta is 2 square root 3 over 3. Okay, we want to find theta. Okay, so we look at the sine. Sine is equal to 1 over cosecant. So which is 3 over 2 square root 3. So this is, if you simplify, it's square root 3 over 2. So square root 3 over 2 we know sine, which is this one, right? So this is pi over 3, which is less than pi over 2. So which implies that theta equals pi over 3. So anyway, you should memorize this table.